Welcome to Professor Hanselkamp. With me here is a question on exponential equations. I want to see how we get to find the value of n in this particular exponential equation. The question reads 9 to the n power minus 4 to the n power equals to 6 to the n power. Find the value of n. Let's get to the solving. So what you're going to do here is to divide throughout this particular equation by 6 to the n power. So divide by 6 to the n power. Also here 6 to the n power. Also here 6 to the power n. Once this is done, we simplify this. If you do so, we're going to have 9 to the n power over 6 to the n power minus 4 to the n power over 6 to the n power, and this is equal to 6 to the n power divided by 6 to the n power. The answer will equal to 1. But then, if you may recall, according to the laws of indices, 9 to the power n over 6 to the power n can also be rewritten as 9 over 6 in the parentheses to the power n minus the same as happens here. We're going to have 4 over 6 to the n power, and this will equal to 1. From there, you can simplify what is inside the brackets here, or the parentheses. What you have is 9/6. So 9/6 can be broken down as follows. This 9 can be rewritten as 3 by 3. This 6 can be written as 2 by 3. Then everything raised to the n power minus this 4 can be written as 2 by 2, and this 6 can be written as 2 by 3, then everything raised to the n power, and then this will equal to 1. When I simplify here, we'll see that the 3's will cancel out. If the 3's cancel out, the 2's cancel out, then we have 3 halves to the n power, 3 halves to the n power minus 2/3 to the power n, and everything has to equal to 1. Once this is done, we are going to say 3 halves, we write it as it is. If you write 3 halves as it is, you can choose which one to make. The idea here should have the same bases here. If here we have 3 halves, here should also have 3 halves. But then how do you go about it? So what we're going to do here is some sort of interchanging of the reciprocals. If you look at the 3 halves can also be rewritten as 1 over, take note, these 3 halves can also be rewritten as 1 over 2/3 raised to the n power, and this will be subtracted, or rather this will subtract the 2/3 to the n power, and this will equal to 1. Once this is done, you're going to further appreciate something here. Now that we have this, it's now easy and possible for us to do something here. So then, with that in mind, it is often it is very important that we see how we go about this one. I'll take you back in time. We had quite a number of things at this particular point here. It therefore follows that at this point we're going to let n letter of our choice, say x, be equal to 2/3 to the n power. If we do so, then we're going to plug in this 2/3 to the n power. Wherever there is 2/3 to the n power, we're going to put x. And if we do that, we're going to have 1 over x minus x equal to 1. From here, you can multiply throughout by x. If you do so, we're going to have x times 1 over x is 1. X times this is minus x squared. X times 1 is x. If you had to rewrite this one, then we're going to have x squared plus x minus 1 is equal to nothing. You solve this equation and this using this particular formula. Minus b plus the square root of b squared minus 4ac, everything all over 2a. Once this is done, you try to collect the coefficients. A is 1, b is 1, c is minus 1. Once this is done, we plug in these coefficients into the formula. Then we have minus the b is 1 plus or minus the square root of b is still 1, a is still 1, c is minus 1, everything to 1. Simplify this, we have minus 1 plus or minus the square root of 1 plus 5, 1 plus 4 rather, all over 2. X is equal to minus 1 plus or minus the square root of 5 all over 2. Once this is done, we're going to split and say either x is equal to minus 1 plus square root of 5 over 2, or x is minus 1 minus the square root of 5 over 2. But then we know here to say, if we go by x is equal to minus 1 minus square root of 5 over 2, we're going to discard this because we're going to have a negative value of x, and we are trying to avoid the negative x values. Therefore, you discard this one. This one will be discarded so that we maintain this one. So then we know here to say x is negative 1 plus root 5 over 2. Once this is done, but we know here to say x, if I take you back, where the let x represent something, x is 2/3 to the n power. Are we seeing? 2/3 to the n power. So then it's logical then to equate these two here. If you do so, we'll have 2/3 to the power of n. This will equal to minus 1 plus root 5 everything over 2. Remember, we want to solve for n. We want to solve for n. We want to find the value of n. At this particular point in time, we're going to introduce what we call the logs. Here we're going to introduce the logs. So when you introduce the logs on both sides, we're going to have log base 2/3 of 2/3 to the power of n. This will equal to log, you maintain the base, 2/3 of negative 1 plus root 5 over 2. But we know here to say, according to the laws of logarithms, we know here to say if you have log base a of a to the n power, that can also be written as n log base a of a. But we know log base a of a is just the same as saying 1. In this case, we're just going to bring this n, which is the exponent, here as a coefficient. So when you bring this one here, we're going to have n times log base 2/3 of 2/3. This is equal to log base 2/3 of -1 plus root 5 over 2. Once this is done, when you simplify further, we know here to say log base 2/3 of 2/3 will give us 1. So it's 1 times n, which is n. So here we have n times 1, which is n. So there we have n is equal to log base 2/3 of -1 plus the root of 5 all over by 2. Then you say, therefore, this is the value of n. Thank you for watching. Please don't forget to subscribe and follow as I post so many questions on such questions and different other topics. Thank you so much for watching. Thank you for your time. Goodbye.